Hey guys, here's my not live review for your makeup assessment tomorrow. The first problem I gave you, you have to consider two functions, f of x equals x plus 5 and g of x equals absolute value of x. Graph f composed with g and g composed with f, and then you're going to compare them and discuss the difference of the plus 5 in the two functions. So we talked about this in both classes, so it shouldn't be new to anyone here, but here it is online, so you can pause and stop and think at your leisure. Your first step here, clearly, is to find f composed with g and g composed with f. So let's start with that. F composed with g means f of g of x, which is, let's see, I'm taking the g of x and plugging it into the f of x. So in f of x, the first thing I see is an x, but instead of that, I'm going to write absolute value of x, because I'm replacing the x with absolute value of x. And then there's a plus 5. And then I'm going to do g composed with f, which equals g of f of x. And in this one, I'm starting in the graph of g, and when I see an x in the graph of g, I'm going to replace it with x plus 5. So in the graph of g, I've got absolute value, and then I see an x, so I'm going to replace that with x plus 5, and then an absolute value. Okay, so those are the two things I need to graph. Well, the nice thing about doing pre-recorded ones is I don't have to bore you with setting up the axes and scaling them and all that. So I'm going to do my first function, f of g of x. I plug in 0, absolute value of 0, add 5, so it's got 0, 5 on it. And then plug in 1, 1 plus 5 is 6, 2, absolute value is 2, plus 5 is 7, etc. Negative 1, absolute value of negative 1 is 1, plus 5 is 6. Negative 2, absolute value of negative 2 is 2, plus 5 is 7. So there's absolute value of x plus 5 goes up that way, and comes down that way. And that's f composed with g. And then we're supposed to do absolute value of x plus 5. So I'm going to plug in, to indicate that that's this one. Now in this one, I'm going to plug in negative 5. Negative 5 plus 5 is 0. Absolute value of 0 is 0. So I get the point negative 5, 0. Negative 6 plus 5 is negative 1. Absolute value of negative 1 is 1. Negative 6, 1. Negative 4 plus 5 is 1. Absolute value of 1 is 1. So I get negative 4, 1. And, as you might have guessed, it's going to go up this way and up this way. So there we've done it. That is g composed with f. So graph f composed with g, check. Graph g composed with f, check. And then we're supposed to say, what different role does the transformation plus 5 play in the two functions? So to finish number 1, we're asked to discuss what different role does the transformation plus 5 play in the two functions. And my answer was that in f composed with g, the plus 5 is added to the outputs of the absolute value function, translating the graph of g of x up 5 units. In g composed with f, the plus 5 is added to the inputs of the absolute value function, meaning that any given x value input in g composed with f will have the same output as an x value input 5 greater in g of x. Thus, g composed with f is a translation of g of x 5 units to the left. To illustrate that, let's zoom back in And though we weren't asked to graph g of x, I can do it here in purple. This would be g of x, the original absolute value function. Absolute value functions, while I'm on the topic, just so happen to be a great example of a piecewise function. If we're going to define an absolute value function, we would define it as an absolute value function. Anyway, here I have the original function. I should label it g of x, and I'm going to separate it from everything else here, and I'm going to point out that if I were to take g of x to g composed with f, it would be a translation left 5. Watch me slide it left 5. Ooh, I left part of it behind. That's bad. Let's put it back together. Translation, ooh, that's no good. Translation left 5. There's a translation left 5. And if I were to take g of x to f composed with g, that would be a translation up 5. Ta-da! We'll just add that in there in orange. So this is the translation by the vector -5, 0. And this is the translation by vector 0, 5. And you guys remember how excited I was. I'll just put it in here because I think it's so cool to point out that we could see that left 5-ness and that up 5-ness equally well when we graphed f of x. Because for f of x, the plus 5 took the graph of x and moved it up 5, if we wanted to think about it that way. Right? Here's x. Here's the graph of x moving up 5 and landing on f of x. Or, just as reasonably, f of x moved the graph of x left 5, if we want to think about it that way. The graph of x, the point 0, 0 went to -5, 0. Both of those, for the graph of the identity function, x, are the exact same motion. But then that motion of up 5 only gets expressed in the blue graph, f composed with g, whereas the motion left 5 is the only one that gets expressed in the red graph, g composed with f. So depending on the order in which we compose f of x and g of x, we're going to see either the left 5-ness or the up 5-ness, which was what was in the plus 5. The plus 5, when it was just here in f of x, had the potential to either be thought of as plus 5 or be thought of as left 5, which is like totally awesome and mind-boggling. Anyway, that's it for number 1. Stay tuned in the next video for number 2.